seeking the sum of the real roots. Yesterday we did the sum of the roots. Today it's just the sum of the real roots. Now notice that very tempting here is to cube, but it's not too tempting once you think about it. So if you did cube the left-hand side, you would end up with a ninth degree equation. A ninth degree polynomial, I should say. Now, if you have a ninth degree polynomial, set it equal to 0, probably most of us would be lucky to figure out it just using numerical. You know, I don't know of a systematic way to really do that. I guess there's special cases where you can. But we would have a ninth degree polynomial equal to 0 with 9 possible zeros. Many of them would probably be complex solutions occurring in conjugate pairs. We're supposed to find the sum of the real roots. Now, something that just really sticks out right here is the presence of the same three terms both on the left-hand side and within the cubic radicand. So a very natural substitution, which turns out to work quite nicely, is u is equal to x cubed plus 7x squared minus 30x. Okay, now let's take a look at how we'll proceed at this point. Now, so with that substitution, u is equal to x cubed plus 7x squared minus 30x. We get the following algebra right here. If we cube both sides of this expression, you see this is actually in the form, this piece right here is precisely in the form of the original equation. Okay, but the nice thing about it is that when you cube both sides, you get this equivalent statement. And u equals to 4 by inspection. Okay, u equals 4 is a solution. Now, it turns out there's two complex solutions to this also, but that's not important because whatever they are, you would set it equal to this and you would get complex solutions. So we're not interested in that. We're interested in the sum of the real roots. Okay, so we'll only consider u equals 4. There are other solutions, but u equals 4 is by inspection. You get 64 minus 4 is 60 minus 60 is 0. All right, now if you set u equals 4 to the original substitution, you'll end up with this statement right here: x cubed plus 7x squared minus 30x minus 4 equals to 0. Okay. So what do we do with this? Well, one, it's tempting to try to solve this, but owing to a very nice result by Vieta, and again, I'll write down the justification for this. Notice that if we had a cubic with 3 zeros or 3 roots, not necessarily distinct. Okay, we'll call them r sub 1 here is one of the zeros or one of the roots. R sub 2. And y'all, this is a basic truth. If you have a 0 or a root, that corresponds to a factor. It's often called the factor theorem. Okay, if you have this, okay, notice that when you expand this out, you'll get x cubed clearly. And then just an essential result, or just a necessary result of the multiplication, would be this statement right here. You will have minus the sum of the roots. And again, you can verify that. It's quite easy to multiply that out. It gets a little more involved for the other terms, but we're only interested in the sum of the zeros. But notice that minus the sum of the roots, that would be r sub 1 minus r sub 1 plus r sub 2 plus r sub 3, turns out to be the coefficient of x squared. Okay, now there's some other, there's more to write down, but it's not necessary, right? You get the product of all pairs, the product of all triples, and all that. That's the essential idea behind Vietas. But owing to that, we can see that just by comparing this 7 with this coefficient. You see 7 is the coefficient of x squared, but minus the quantity, or minus the sum r1 plus r2 plus r3, that you have to equate that. That's the essential idea. And so if you write down 7 is equal to minus r sub 1, and again, we don't even know what the roots are, but we know that this holds based on just the expansion we just wrote down. Okay. Okay. Again, y'all, not to beat a dead horse, but all that really happened here was we have a plus 7 as the coefficient of x squared right here. We know that this third degree polynomial has 3 roots, not necessarily distinct. And so when you expand this out, this is what happens. And again, you can verify that if you don't believe me. All right. But what that means is that minus 7 is equal to the sum of the roots. And the beauty of this is there's no messy calculations finding the roots or the zeros. So that's the answer to our question, folks. Negative 7 is equal to the sum of the roots. Now, I will point out to you that there's something called a discriminant. I don't know much about it. It's analogous to the discriminant for second-degree equations. But it turns out that the discriminant here, if you take, in this scenario right here for A, we would have A equals 1. Okay, this is our cubic up here. B is equal to 7. Right? C is equal to negative 30. And D is equal to negative 4. Now, I'm not going to go through the calculation with you, but if you hand this off to this discriminant right here, this is the discriminant. Again, I read up on this, and I don't want to go through all the details of it. I think I roughly understand why what it's saying is true, but it turns out this is greater than 0. Okay, for these choices of constants, A equals 1, B equals 7. C is equal to minus 30, and D is equal to negative 4. If you do go through all this and do the arithmetic, you get that it's greater than 0, but that implies 3 distinct real zeros. 3 distinct. And the distinct part really isn't so important as far as the problem we're doing here. It's not important at all, in fact. But what is important is that they're real zeros. Okay? 3 distinct real roots. Is what that implies. And again, I'm repeating myself, but I don't think the fact they don't have to be distinct necessarily for what we're trying to do. What's important is that they're real, okay? And so what we know is that the sum definitely is minus 7, the sum of the real roots, because in this scenario, you wouldn't produce any complex zeros. You would produce only real zeros. And by this thing we call Vietas right here, this whole thing right here, what I did is the basis for Vietas. Now, there's more to Vietas. You can look at the coefficients of the other variables like x and all that, but we don't need that here. But this expansion right here is a justification for part of Vieta's formulas. This is the answer, folks. Negative 7. Okay, negative 7. This coefficient with its sign reversed is the answer. Let me come back up here and write that down right here. Minus 7 is the sum of the real roots. And we didn't really have to do a whole lot of work computationally there. Thank you for viewing.